The Atlantic Ocean has produced some of the deadliest hurricanes and winter storms in recorded history. In the North Atlantic, waves can rise higher than buildings, while freezing winds and dense fog erase entire horizons within minutes. Thousands of ships have vanished there across centuries of storms and violent seas. But what makes the Atlantic truly dangerous is not only its power. It is the unsettling feeling that this ocean never fully rests, even for a moment. The Atlantic Ocean feels unstable because it is built from collision. Warm water moves northward from the tropics, while freezing Arctic air pushes downward from polar regions. Storm systems cross open oceans searching for energy. Winds shift direction across enormous distances as pressure systems rise and collapse continuously above the sea. The Atlantic is not calm by default. Its normal state is conflict. This conflict begins with one of the most powerful ocean currents on Earth, the Gulf Stream. Warm tropical water flows northward along the eastern coastline of North America before stretching across the Atlantic toward Europe. At first glance, the current appears almost invisible from the surface, but its influence is enormous. The Gulf Stream transports massive amounts of heat through the ocean, warming surrounding air and altering atmospheric conditions across entire regions. Without it, parts of Europe would experience dramatically colder climates. The Atlantic does not simply move water, it redistributes planetary energy. And where energy moves, instability follows. As warm, moist air rises above Gulf Stream waters, it eventually encounters colder air masses descending from the Arctic. The meeting point between these systems becomes highly unstable, especially during winter months when temperature differences grow extreme. Cold, dense air pushes downward. Warm, humid air rises upward. Pressure shifts rapidly. Wind accelerates, and the Atlantic begins manufacturing storms. This process creates some of the harshest weather conditions on Earth. North Atlantic winter storms can develop with astonishing speed as atmospheric pressure drops rapidly over open ocean. Winds intensify into violent systems capable of generating enormous waves and near-zero visibility. To sailors, these storms often feel less like weather and more like environmental collapse. The sea darkens, the horizon disappears. Wind and water merge into a single moving force difficult to separate visually. And unlike storms over land, Atlantic storms strengthen across vast stretches of uninterrupted ocean where nothing slows them down significantly. This is one reason the North Atlantic became historically feared long before modern forecasting existed. Early transatlantic voyages crossed waters where storms formed unpredictably from colliding air systems humans barely understood scientifically. Ships vanished into fog. Icebergs drifted southward through shipping routes. Freezing spray covered decks with ice heavy enough to destabilize entire vessels. The Atlantic developed a reputation not only for violence, but for sudden violence. Conditions could deteriorate frighteningly fast. Even today, rapid intensification remains one of the Atlantic's most dangerous characteristics. Atmospheric systems over the ocean can reorganize quickly as warm water feeds moisture upward into unstable pressure zones. A manageable storm may become severe within hours. A stable route may suddenly become dangerous. And because the Atlantic connects tropical and polar regions so directly, its storms often carry dramatic temperature contrasts within the same system. Warm rain transitions into freezing wind, dense fog becomes violent turbulence, calm seas transform into chaotic wave fields. The ocean behaves like a battlefield between competing climate systems. Hurricanes reveal another dimension of this conflict. During hurricane season, warm Atlantic waters provide enormous energy for tropical storm development. Heat evaporates water continuously into the atmosphere, while rotating pressure systems organize above the ocean surface. At first, these systems may appear relatively small from satellite imagery. Then they grow. Cloud structures expand outward, winds tighten around falling pressure centers. The Atlantic begins converting stored ocean heat into rotational violence. And once hurricanes strengthen fully, they reshape entire coastlines. Storm surge floods cities. Waves destroy infrastructure. Rainfall overwhelms rivers and drainage systems. But even hurricanes eventually lose strength after leaving warm water behind. The Atlantic's violence depends on energy transfer between ocean and atmosphere. Movement creates instability, and instability creates storms. Yet not all Atlantic storms are tropical. Some of the most dangerous systems form when cold Arctic air collides directly with warmer Atlantic moisture in extratropical cyclones. These storms dominate northern ocean regions during colder months and can become enormous in scale. Unlike hurricanes with clear circular structures, North Atlantic winter systems often feel chaotic and sprawling. Multiple fronts interact simultaneously, wind direction changes abruptly, wave patterns become confused and unstable. For ships caught inside them, navigation becomes psychologically exhausting. The Atlantic removes predictability first, then safety. Fog intensifies this disorientation further. Warm, moist air flowing across colder water creates dense fog banks capable of erasing visibility almost completely. Historically, some of the world's busiest shipping routes crossed regions where storms, icebergs, and fog combined into environments of extraordinary navigational danger. The ocean concealed threats naturally, and still does. Perhaps this is what makes the Atlantic different from the Pacific. The Pacific often feels vast and planetary, an enormous engine generating weather through sheer scale. The Atlantic feels confrontational, compressed. Its violence emerges from direct atmospheric collision rather than open ocean expansion alone. Warm against cold, pressure against pressure, storm systems against currents, everything interacting inside relatively confined space compared to the Pacific's enormous breadth. The result is an ocean that rarely feels stable for long. And maybe that instability explains why the Atlantic has shaped human fears so deeply across history. Explorers, fishing fleets, cargo ships, military convoys, and passenger vessels all crossed waters where weather could reorganize itself faster than human preparation allowed. Even modern forecasting cannot fully remove this uncertainty, because the Atlantic is not a peaceful system interrupted occasionally by storms. Storms are part of its natural balance. The ocean survives through movement, collision, and constant redistribution of energy between sea and sky. And beneath every temporary calm, those opposing forces remain in motion already, waiting to collide again.
The Atlantic Ocean does not always destroy through direct force. Sometimes it begins with confusion instead. A horizon disappears. Fog swallows distance. Wave patterns stop making sense. And slowly, the human ability to understand the environment begins collapsing long before the storm itself fully arrives. This psychological disorientation has defined the Atlantic for centuries, especially in the North Atlantic, where cold Arctic water collides with warmer air masses moving across the ocean's surface. These collisions create enormous fog banks capable of reducing visibility to almost nothing. Ships enter clear conditions one moment and vanish into gray emptiness the next. There is something uniquely disturbing about fog at sea. On land, fog usually exists within stable geography. Roads, buildings, and terrain still provide orientation even when visibility weakens. The Atlantic removes those reference points completely. No landmarks, no stable ground, only moving water beneath a sky that disappears into the ocean itself. The world loses edges, and once distance becomes invisible, human perception begins failing rapidly. This was especially dangerous during earlier centuries of navigation, when sailors relied heavily on visual positioning. A ship entering dense Atlantic fog could lose awareness of surrounding vessels, icebergs, coastlines, or approaching storms within minutes. Even sound became distorted. Fog absorbs and reshapes noise strangely over open water. Ship horns echo unpredictably across the ocean, while waves strike unseen in darkness nearby. Sailors often heard danger before they could see it, and sometimes they never saw it at all. Iceberg regions intensified this fear further. In colder Atlantic waters, enormous masses of ice drift southward from Arctic regions into shipping lanes hidden partially beneath the ocean's surface. Only a small portion of an iceberg remains visible above water, meaning most of its size exists invisibly below. Fog and ice together create one of the Atlantic's most psychologically hostile environments. Visibility collapses, temperature drops, and somewhere ahead may exist an object large enough to destroy steel without warning. The Atlantic became infamous not only because ships sank there, but because sailors often felt blind before disaster occurred. Waves contribute to this disorientation in different ways. Unlike controlled water movement near coastlines, open Atlantic wave systems often overlap from multiple directions simultaneously. Storm swells generated far away intersect with local weather conditions, creating irregular sea surfaces difficult to predict visually. The ocean loses rhythm. This matters more than many people realize. Humans navigate motion partly through pattern recognition. When waves behave consistently, ships can adjust movement naturally. But in unstable Atlantic conditions, waves may arrive from conflicting angles without predictable timing. A vessel rolls unexpectedly. The horizon tilts violently. Balance disappears. Fatigue grows rapidly as the body struggles to adapt continuously to chaotic movement. And then there are rogue waves. For centuries, sailors described sudden walls of water appearing far larger than surrounding seas. Many experts dismissed such reports as exaggeration until modern instruments confirmed their existence. The Atlantic can produce waves rising dramatically above nearby swells through temporary concentration of ocean energy. These waves emerge without emotional warning signs. No gradual escalation, no obvious transition. One moment, difficult conditions. The next, a massive wall of water rising from darkness. Rogue waves feel unnatural because they violate expectation itself. Human beings survive dangerous environments partly because danger usually follows recognizable patterns. The Atlantic occasionally breaks those patterns completely. Storm darkness intensifies everything further. During severe Atlantic storms, visibility may collapse not only from fog, but from rain, sea spray, and low cloud cover merging into nearly continuous gray or black conditions. The ocean surface disappears beneath crashing water and wind. Sky and sea become indistinguishable. Up and down lose clarity inside violent ship movement. And perhaps this is what makes Atlantic storms psychologically exhausting even for experienced sailors. The environment becomes unreadable. Humans evolved depending heavily on visual certainty to survive. The Atlantic strips that certainty away layer by layer. First, distance disappears. Then orientation weakens. Then prediction fails. Only after that does physical danger fully arrive. Cold water shock creates another hidden threat. In many Atlantic regions, especially farther north, water temperatures remain low enough to incapacitate humans within minutes after sudden immersion. This danger is deeply deceptive because people often associate drowning mainly with inability to swim. But cold Atlantic water attacks the body immediately through physiological shock. Breathing destabilizes, muscles tighten, coordination weakens rapidly. Even strong swimmers can become helpless surprisingly quickly in freezing conditions. And storms make rescue extraordinarily difficult once visibility collapses. Maybe this is why so many Atlantic disappearances feel unresolved historically. The ocean often destroys orientation before destroying vessels completely. Ships lose navigation, Aircraft encounter unstable weather and turbulence. Communication weakens beneath atmospheric interference. Then, the Atlantic absorbs evidence rapidly. Wreckage scatters, fog closes again, storm systems continue moving, and the ocean returns to apparent emptiness. There is also something emotionally unsettling about how ordinary the Atlantic can appear before conditions deteriorate. Calm seas may hide distant storm systems already generating massive swells moving invisibly across the ocean basin. A quiet horizon does not guarantee safety. Fog may form suddenly, pressure may shift rapidly, waves may reorganize without warning. The Atlantic changes character quickly because it exists between constantly colliding climate systems. And humans struggle psychologically in environments where stability disappears without clear boundaries. Maybe that is the deepest danger of the Atlantic. Not simply its storms, not simply its waves, but the way it slowly removes human confidence in perception itself. Because once the ocean becomes impossible to read clearly, fear arrives long before destruction does.
The Atlantic Ocean rarely remains still long enough for life to depend on stability. Storms move across its surface continuously. Cold and warm currents shift biological boundaries. Food appears and disappears according to temperature, pressure, migration, and seasonal change. And yet, the Atlantic remains full of life. Not because its creatures overcome chaos, but because they evolved inside it. Survival in the Atlantic depends less on resisting movement and more on understanding it. Whales are among the clearest examples of this adaptation. Humpback whales, fin whales, and blue whales travel enormous distances across the Atlantic, following feeding cycles linked to changing ocean conditions. These migrations are not random. They are responses to moving ecosystems. Cold northern waters often become rich feeding grounds during certain seasons because nutrient circulation supports explosions of microscopic life. Krill and fish populations increase, drawing whales into regions that may later become harsh and storm-dominated during winter months. The Atlantic rewards timing. Remain too long in one region and conditions change. Move too early and food may not yet exist. The ocean forces life into constant adjustment. Whales survive partly because they read environmental signals across vast distances. Water temperature, currents, salinity, and even underwater acoustics help guide movement through unstable marine landscapes. To humans, the Atlantic may appear chaotic. To whales, it is dynamic but readable, at least most of the time. Storms still create danger even for massive marine animals. Young whales can become separated during severe conditions. Rough seas increase energy demands during migration. Food availability shifts dramatically after changes in temperature or current patterns. Nothing in the Atlantic survives permanently through strength alone. Adaptation must remain continuous. Seals experience this reality differently. In colder northern Atlantic regions, seals move between ice edges, coastlines, and open water systems shaped constantly by seasonal storms and shifting temperatures. Ice itself becomes unstable habitat. Storms break it apart, currents move it unpredictably, and climate fluctuations alter its distribution across entire regions. The Atlantic does not provide fixed environments. It provides temporary opportunities between disturbances. Sharks reveal another layer of survival inside this ocean. Species such as mako sharks and great white sharks patrol enormous Atlantic territories where prey distribution changes continuously according to water temperature and migration routes. Warm currents attract life. Cold currents redistribute nutrients. Storm systems alter ocean chemistry and prey movement. Predators must remain mobile enough to follow these shifting conditions or risk starvation. Again, survival depends on movement, not permanence. This principle extends even to smaller Atlantic fish populations. Massive schools of herring, mackerel, and tuna migrate according to environmental changes occurring across enormous distances. Currents function almost like moving highways, carrying nutrients and biological activity throughout the ocean basin. Where currents collide, life often intensifies, but those productive zones may shift constantly depending on season and weather. The Atlantic ecosystem behaves less like a stable map and more like a continuously rearranging network. Seabirds perhaps understand this instability better than any other Atlantic creatures. Albatrosses, petrels, and shearwaters spend much of their lives above open ocean, where storms dominate daily existence. These birds exploit Atlantic wind systems with astonishing efficiency, gliding enormous distances while using atmospheric movement itself as energy. A violent storm that terrifies humans may become a navigational advantage for seabirds adapted to dynamic wind patterns. Again, the difference lies in evolutionary perspective. Humans see storms as interruptions. Atlantic wildlife experiences them as part of normal environmental structure. Even beneath the surface, the Atlantic never stops moving. Deep ocean currents transport cold, dense water across enormous distances through slow planetary circulation systems. Nutrients rise upward through upwelling zones, while warmer surface water travels elsewhere. The entire ocean breathes through movement, and life synchronizes itself to those rhythms. Perhaps this is why Atlantic ecosystems often feel emotionally different from ecosystems in calmer environments. Tropical forests may appear rooted and geographically fixed. The Atlantic feels transitional. Everything travels, everything responds, everything depends on timing against systems larger than individual organisms. There is also brutality hidden inside this constant movement. Migration demands enormous energy. Storms interrupt feeding opportunities. Young animals face extreme vulnerability during early life stages when weather shifts unexpectedly. The Atlantic does not guarantee survival simply because a species evolved there successfully for generations. Every year, storms still kill. Cold still overwhelms.
Food shortages still emerge when ocean conditions change too rapidly. Life survives there through probability and adaptation, not certainty. Orcas demonstrate perhaps the most sophisticated response to this instability. Different Atlantic orca populations develop hunting strategies shaped by local prey movement and environmental conditions. Some target fish schools, others hunt seals or larger marine mammals, but all depend heavily on cooperation, intelligence, and flexibility. The Atlantic changes too quickly for rigid survival strategies. The most successful predators are often the most adaptable. And maybe that is the deeper lesson hidden inside the Atlantic wildlife. The creatures surviving there do not conquer the ocean. They negotiate with movement constantly. Storms arrive, currents shift, food disappears, temperature changes, and life responds again and again without expecting permanence. Because permanence doesn't truly exist in the Atlantic, only temporary balance between periods of instability. And perhaps that is why this ocean feels so alive. Not because it is peaceful, but because everything within it must remain in motion simply to survive.
For centuries, the Atlantic Ocean represented both connection and fear. It linked continents, enabled trade, carried explorers, transported armies, and helped build the modern world. Entire economies grew around the ability to cross it efficiently. And yet, despite radar, satellites, steel hulls, aircraft navigation systems, and modern forecasting technology, the Atlantic still overwhelms humans with unsettling regularity. Not because technology is weak, but because the Atlantic changes faster than certainty can keep up. This ocean remains one of the busiest transportation corridors on Earth. Cargo ships cross the Atlantic continuously, carrying fuel, machinery, food, vehicles, and electronics between continents. Passenger aircraft move above it daily along tightly organized routes through shifting atmospheric conditions. From a distance, the appearance is controlled, precise, engineered.
But beneath that appearance lies constant environmental negotiation. Every Atlantic crossing depends on weather windows, pressure systems, wave forecasts, wind conditions, and ocean behavior that can reorganize rapidly within hours. The Atlantic rarely grants stability for very long. This becomes especially dangerous during winter in the North Atlantic. Cold Arctic air descending southward collides with warmer ocean systems, generating violent extratropical storms capable of producing hurricane-force winds and enormous waves. Ships crossing these regions may encounter conditions so severe that progress slows dramatically despite modern engines and navigation systems. Steel groans under pressure. Containers break loose. Decks disappear beneath freezing water, and suddenly even massive vessels begin feeling fragile again. The ocean reduces scale psychologically. A ship that appears enormous inside a harbor can feel frighteningly small in open Atlantic storms. Perhaps this is why sailors still speak about the Atlantic with unusual respect. Technology improves survival probability, but it does not eliminate vulnerability. The environment remains larger than the machine crossing it. Fishing fleets experience this reality more directly than almost anyone else. Many Atlantic fishing grounds lie inside regions famous for unstable weather, dense fog, freezing conditions, and unpredictable seas. Crews work on moving decks coated in ice while storms reorganize around them continuously. Fatigue becomes dangerous. Visibility disappears. Equipment failures escalate quickly into life-threatening emergencies because rescue may remain hours away through severe conditions. The Atlantic punishes delay harshly. A problem manageable on land may become catastrophic at sea simply because the environment keeps moving aggressively against human response time. Cold water remains one of the greatest hidden dangers. In northern Atlantic regions, immersion in freezing water can incapacitate humans within minutes through cold shock and rapid heat loss. Modern survival equipment improves chances significantly, but survival windows remain brutally short during severe conditions, and storms complicate rescue operations further by reducing visibility, increasing wave height, and scattering debris across enormous distances. Aircraft crossing the Atlantic face different but equally serious challenges. Turbulence generated by Atlantic jet streams and storm systems can become extremely violent, especially where warm and cold air masses collide sharply. Pilots depend heavily on atmospheric forecasting because conditions change rapidly above the ocean. Routes adjust constantly according to storm development, pressure systems, and high-altitude wind patterns. Yet, forecasting has limits. Unexpected turbulence still injures passengers. Storm systems intensify faster than expected, and communication or navigation complications become psychologically heavier when thousands of kilometers of ocean exist below. The Atlantic creates isolation even in the modern age. Perhaps the most unsettling reality is that the Atlantic still produces situations where humans lose environmental awareness despite advanced technology. Dense fog interferes with visibility, storms disrupt radar clarity, ice accumulation damages equipment, satellite communication weakens under extreme atmospheric conditions. The ocean attacks certainty itself, and human systems depend deeply on certainty to function safely. This explains why Atlantic disasters often feel emotionally different from accidents on land. On land, infrastructure usually remains stable during emergencies. Roads stay visible, buildings remain fixed, rescue systems operate from nearby locations. At sea, the environment itself becomes unstable. The ground moves, visibility collapses, direction loses clarity, and the Atlantic continues changing while humans attempt to respond. There is also a deeper contradiction hidden inside modern ocean technology. The more efficiently humans cross the Atlantic, the easier it becomes to forget how dangerous it remains. Large cargo vessels feel secure, aircraft seem routine, forecasting models appear precise, but none of these systems remove the Atlantic's underlying unpredictability. They only reduce exposure temporarily, because the ocean itself is not stable. Storm tracks shift unpredictably as atmospheric conditions change. Climate fluctuations alter hurricane behavior and seasonal storm intensity. Ocean temperatures influence wave development and pressure systems in ways scientists still study constantly. The Atlantic remains dynamic beyond complete human control. And maybe this is why even modern crews describe severe Atlantic storms with language that sounds ancient. The sea becomes black. The horizon disappears. Wind screams across metal structures, and technology suddenly feels less like dominance and more like temporary protection against forces vastly larger than civilization itself. Yet humans continue crossing, again and again, because the Atlantic remains essential to global life despite its violence. Trade depends on it, economies rely on it. Entire nations connect through routes passing directly across unstable ocean systems. Human civilization cannot avoid the Atlantic. It can only negotiate with it continuously. And perhaps that's the final truth modern technology reveals. The Atlantic was never conquered. Humans simply became better at surviving inside conditions that still remain fundamentally beyond their control. Atlantic Ocean has never truly been a place of stillness. Its storms are born from collision. Warm currents rise northward while Arctic air descends across open water. Waves travel through overlapping systems of wind and pressure that never stop moving for long. Everything about the Atlantic depends on instability, and yet life continues within it. Whales migrate through storm corridors. Seabirds glide above violent winds. Fishing vessels cross freezing seas despite knowing how quickly conditions can turn deadly. Cargo ships and aircraft continue moving between continents across an ocean capable of erasing certainty within hours. Not because the Atlantic became safe, but because humans learned to survive temporarily inside its motion. Perhaps that is why this ocean still feels psychologically different from others. The Atlantic does not merely appear powerful, it feels restless, like an environment permanently caught between opposing forces that can never fully settle. And maybe that is the deeper truth hidden beneath its storms and fog. The Atlantic was never designed for permanence. It was shaped by movement, pressure, collision, and change long before human civilization existed. Every calm horizon above it is temporary. Every quiet crossing depends on conditions that may disappear at any moment. Because the most unsettling thing about the Atlantic is not its largest storms, but the realization that this ocean has never truly been peaceful. Humanity has simply learned to travel through brief moments of calm between systems of chaos already forming beyond the horizon.
you.